I'd like to show you a pretty quick way of breaking a number into its primes. This is called prime factorization. Here's the number 138, and clearly it's divisible by 2 because it's even. So I'm going to draw an upside down division sign around that, put my 2 out in front. 2 goes into 13 6 times with 1 left over. So 6 times 2 is 12. 12 plus 1 is 13. 2 goes into 18 9 times. Then I'm going to draw that upside down division sign again. Well, 69 clearly isn't divisible by 2, but it is divisible by 3. How do I know that? Because 6 is divisible by 3 and 9 is divisible by 3. So I'll put the 3 out front. 3 goes into 6 2 times. 3 goes into 9 3 times. Since 23 is in my list of primes, then I'm done factoring 138. It is 2 times 3 times 23. Let's try another number. This is 360. 360 is clearly divisible by 2 because it's even. 2 goes into 3 one time. 3 take away 2 is 1, so there's going to be 1 left over. 2 goes into 16 8 times, and that's exactly enough, so we bring down the 0. That's even, so it's divisible by 2 again. 2 goes into 18 9 times exactly, bring down the 0. This is even again, so another 2. 2 goes into 9 4 times with 1 left over. 2 goes into 10 5 times. Now at this point you might think that 45, the next prime that goes into 45 is 5 because it ends in a 5. But let's do the divisibility test for 3. 3 doesn't go into 4, 3 doesn't go into 5. However, 4 plus 5, we're adding the digits of the number together, equals 9. Since 9 is divisible by 3, then 45 is also divisible by 3. So 3 into 4 goes 1 time with 1 left over. 3 goes into 15 5 times. Well, 3 goes into 15 5 times. So the prime factorization of 360 is 2 times 2 times 2 times 3 times 3 times 5. And the shorter way to write that, more condensed, is 2 to the third, 3 squared times 5. Okay, let's try a not very nice number. This is 1,755. Now, again, it ends in 5, so you might want to start with 5. You could. You would find all the factors. But let's start with the smallest one that we can find first. So here's my upside down division sign. And let's add the digits together to see if that might be divisible by 3. 1 plus 7 is 8. 5 plus 5 is 10. So 8 plus 10 is 18. So yes, 18 is divisible by 3. So 1,755 is divisible by 3. 3 goes into 17 5 times, this time with 2 left over. 3 goes into 25 8 times, this time with 1 left over. 3 goes into 15 5 times. Well, let's check again for divisibility by 3. 5 plus 5 is 10. 10 plus 8 is 18. 18 was divisible by 3 here, so it should be divisible by 3 here. So 3 goes into 5 1 time with 2 left over. 3 goes into 28 9 times with 1 left over. 3 goes into 15 5 times. Check once again for divisibility by 3. 1 plus 9 is 10, plus 5 is 15. 15 is divisible by 3, so 195 is divisible by 3. 3 goes into 19, 3 times 6 is 18. That would be 1 left over. 3 times 5 is 15. Okay, 6 plus 5 is 11. So that's not divisible by 3. And the next largest prime would be 5. And since this ends in 5, this clearly will be divisible by 5. So 5 goes into 6 one time and 1 left over. 5 goes into 15 3 times. Since 13 is a prime in my list, then I'm done here. And I can rewrite, there we go. I can rewrite 1,755 as 3 times 3 times 3 times 5 times 13, or shorter, 3 to the third times 5 times 13. And that's prime factorization using upside down long division.